think we can proceed to the questions for all the different presentation in the aspects. So all of you can write also in the QA session or raise your hand to get your microphone unmuted. Just a quick question from my side. It was more on what to Tahani about the presentation regarding the began sorry, the hotspot lithography. So
in which slides?
Maybe if yes, in the previous slide. Sorry.
This one?
No, I mean in the first part of the presentation before the began, in the convolution neural net of hotspot detection. So I think it's in the second part of the talk, a bit.
After the break, yes.
Exactly.
Okay.
Here, exactly.
Yeah.
So, Tahani, my question was, did you have any specific convolution neural net like AlexNet, or it was some architecture that the proposed method seems to work better than the others, or they provide some intuition about the convolution neural network that they take?
Actually, this depends on the kind of data set that we treat with the convolutional neural network. For example, in this paper, they preferred to build like neural network from the scratch in order to be very well fit to the problem. But actually, also they suggested to use the transfer learning by using network or any other valuable model to be used. But actually, this is different from problem to problem. But here they preferred to use like models building from the scratch according to the data set.
Okay, thank you very much for answering. And one more question to Olympia. So for this particle swarm optimization, my question was, have you considered having some other methods, some other computational methods like genetic algorithms or different optimization methodologies? I think, Olympia, we cannot hear you.
Sorry, thank you very much. Yes, actually, this is a very interesting topic. Yes, there are other techniques that have been explored in the area of electromigration aware design. Genetic algorithms, for example, is a very powerful optimization tool. And the thing is that a genetic algorithm is inspired by natural selection, mutation and selection crossover in order to evolve to better solutions over multiple generations. And PSO, particle swarm optimization, on the other hand, and this is the reason why we have chosen this method, is based on collaborative learning. Where candidate solutions, particles, adjust their position based on both their own experience as well as the swarm's best known solution. So particle swarm optimization tends to be faster and actually more efficient to find the best solution, since the first genetic algorithm can introduce randomness due to the mutation and selection. But the thing is that a very interesting approach would actually be to combine these two, in order to make the optimization problem better, because we can combine the mutation and selection in order to explore more in a better way the search space, and on the other hand, PSO in order to be more efficient to convert into a specific solution. So yes, actually, that was a very nice point. Thank you for the question.
Thank you, Olympia. We have two questions in the chat. I think both are for Tahani. So the first is, since there's a data scarcity how do the data diversity is ensured? Is there any occurrences of bias?
Yeah, thank you. This is very interesting question. Actually, when we talk about the source data that been used on the training, and after that we used like a few data for the fine tuning. In the first stage, which is when we use the source data to the training, it actually include a lot of different images for the urban satellite images, and this can help to increase the data diversity. But actually, when we talk about the fine-tuning stage, if we are so lucky, we will have different benchmarks for 10 different. If they are almost the same, we could have kind of bias, but it's not will be a big issue, because we always try to generate data suitable to the main goal or the target data. So in this case, actually based on the data available in the fine-tuning stage. But actually here in the fine-tuning stage, almost the data, it's not the same, it's more diverse, so it could be a little bit away from the bias.
Perfect, thank you. And I think there's one more question in the chat. So the question is about the quality of the generated data by transfer learning in the began presentation, and if there are techniques that ensure the quality in comparison to real data.
Actually, the quality of generated data, it's based on the quality of the model and the amount of data that have been used on the training. In the first few could have very bad quality data, but actually after, for example, 10,000 rounds or more, we have more quality data, or actually very typical data to the real data, because every time we train the model for example 10,000 or 20,000 rounds, we improve the quality to become very high, to generate images very close to the real images. So it will generate very high quality images.
Thank you, Tahani. I think also there's a question regarding Olympia. So why is the hardware world so behind in having strongly established open source alternatives, and what can be done to achieve that, and how would that affect academic research on this field?
Yes, actually, another very nice question. Traditionally, EDA is very behind in open source adoption, actually, in general, and there are a lot of barriers for that. First things first, not a lot of people do hardware, and specifically EDA. So apart from that, the thing is that it has high complexity and cost. The workflows for EDA are multi-stage and extremely complex that require precise modeling and verification and fabrication considerations. So it requires significant resources and expertise in order to do that, which makes the pool even smaller. Also, it's the fact that there is foundry, the proprietary foundry processes. And the thing is that the PDKs belong to some companies, and they are generally not openly available. And they are so the EDA community cannot leverage from real world applicability. And this is also a problem for research in general. And that is why Open Road and such projects actually exist, so that, and that is why the democratizing hardware, as we can see, slide 39, if you please, Yixian, go there. That is why the slogan 39.
30.
Thank you. Yes,
Yeah.
thank you very much. And that is why it is the slogan democratizing hardware design. There is an extremely large need in order to have more open source hardware design and EDA tools in order to make research more available, actually. I hope this answers your question.
Thank you, Olympia. Thank you for the answer. I think we have one more question from the audience. I think Mr. Athanasios Teuvaras, you can unmute your microphone.
Thanks, George. First of all, hi everyone, and thank you very, very much for these wonderful presentations. I have two questions. The first one is for Dr. Tahani and considers this convolutional neural network that processes images. And I was wondering your take, Dr. Tahani, on the resolution of such images. So, for example, what happens if we have some data with low resolution images? Does it seem that contemporary neural network architectures can withstand that level of noise, or will our results get deteriorated so much that they will diverge from the ground truth? This is the first one.
Can you repeat the last part of the question about the image noise, please?
Yes, sure. So, what happens if the image resolution is low? Does the neural network, the convolutional neural network, can it deal with that noise? It's not exactly noise. Let's say low quality data due to low resolution. Can the neural networks deal with that, or do their outputs deteriorate much?
Actually, this will not affect a lot of the model, because when we deal with convolutional neural network, we move the image for the gray level to be like all the colors between the white and black, and the important feature, it will be like more like very clear, and the not important feature, it will not be appeared. And also when we deal with the convolutional neural network, the convolutional neural network actually did something called like the feature extraction, and try to extract the main important feature. As we can see here in this figures, we will deal actually with pixels in the gray level, and so extract the main feature from such images, it will be much more easier than dealing with images when in like 3 types of colors, or only different kind of images. So in this case, it will not be like very issue the quality of images, especially if we have like such kind of patterns. It's not very complicated patterns. It can be easy to define, and it can be easy to have it like very clear compared to the noise.
I see. Thank you very much for your response. The next question is for Dr. Shen. So there was a slide, I don't remember the name, where a deep learning model, if I am not mistaken, was used. And I would like to elaborate a bit on the usage of it. For example, was it for decision-making purposes? Was it for scheduling purposes? Perhaps you said that, but I lost it on the whole presentation. Could you please repeat why a DQL model was used? What was the purpose of it?
Yeah, so the DQA model is used to capture the low power model for the memory bank, and the DVFS for the core. The DQN is trying to learn the cooperation, the coordinate, the integration of these two actions. And when this model is trained, and we compile it to the binary file and put it to the commit for the scheduling. The DQM is like an agent, like a scheduler.
Okay. Thank you very much.
Yeah.
Thank you all for the question and the answers. So are there any other questions? So if there is no other question, I would like to thank you for your participations in the webinar. And I think this was the first webinar of our series. We're going to have another 2 webinars with more content. We're going to upload the slides to have them publicly available on our site, on COIN-3D project. So thank you very much for attending, and hope to see you also in the other webinars as well. So have a nice day all, and good afternoon.